Sometimes you don't feel like moving at all, and that's alright. Apparently, science also says that laziness is a general property of all objects in this universe. Let's explore why. Let's explore the ordinary and let's dive into the laziest concept in physics that keeps cars, planets, and even you in line. In 300 BC, Aristotle believed that if the applied force on the object was removed, the object would stop moving. Although Aristotle's idea was completely wrong, he opened up the floodgates for great scientists like Johannes Kepler and Galileo to ponder upon this topic. And eventually, Sir Isaac Newton laid down the mathematical fundamentals of inertia, famously known as the first law of motion or the law of inertia. Well, to keep it simple, inertia means laziness. In fact, it's derived from a Greek word called iners, which means lazy. You all get it, right? The first part says that an object continues to be at a state of rest unless acted upon by an external force, which is fair. Something that is not moving will only move when you apply force to it, right? The second part says that an object that is in motion continues to be in motion unless and until acted upon by an external force. Now, this is the tricky one. It means that if a friend of mine has pushed a toy car towards me, it shouldn't stop, it should move on forever. Now, that's something that we don't see in the real world. So, what's happening here? The law of inertia stays intact and does not break down. Because in the real world, we have things like friction, air resistance, water resistance, atmospheric resistance that basically slow down the object and bring it to a complete stop. If we want to see inertia playing out perfectly, we would need a frictionless environment or get inside a rocket and fly to outer space.
So guys, I'm going to show you some examples while driving. Please don't try this at home.
We might feel still, but our body is moving at the same speed as the vehicle. When we apply the brakes, as per the law of inertia, our body tends to continue that motion. That's why we feel the jerk when the brakes are applied. In case of an extreme situation, seatbelts can be your best friend. Next, we have the classic carpet and the stick example. The carpet has dust particles which are at rest. When we hit the carpet with a stick, the carpet experiences a jerk, and because of which the dust particles fall off. Here, the card and the object are at rest. When the card is flicked, the object above the card continues to be at rest and hence falls into the glass. In doing this, I ended up breaking a glass. Now I'm going to feel inertia at home. So we all know that the Earth rotates around its axis. So at the equator, the speed of that rotation is around 1670 kilometers per hour. Now, what would happen if the Earth suddenly stops moving for 1 second? Well, everything at the equator and on Earth will have a sudden jerk and move from west to east at a speed of 1670 kilometers per hour. That's intense. There would be people, buildings, trees, everything flying at 1670 kilometers per hour. That's mind-blowing. There would be cyclones and winds and tsunamis that have never been registered on this planet. It would be a complete disaster and a complete catastrophe. Maybe that's when some Earth seatbelt startup might come into play. Can we save ourselves in all this if this happens? Now, the speed at which the Earth rotates at the equator is 1670 kilometers per hour. But at the poles, the speed would be almost zero. You can take a ball and you can rotate it. It would move faster at the equator, and at the poles, it would move slower. So, the rotational speed at poles is almost 0 kilometers per hour. If we are at the poles, we would have a better chance of survival as compared to anywhere on the planet. Crazy, right? Well, this is Arjun signing out. Do hit the like button, and I'll catch you in another video with another concept. Till then, take care and see you.